Hi there, my lovely Longhorns. It's Miss Campbell, and today we're going to go through dilations about the origin. So, a dilation is a transformation that enlarges or reduces the size of a figure while keeping its shape. So, it's kind of like on a computer, if you drag a picture from the corner, you make it like bigger and smaller, right? Like zooming in and zooming out. That's what a dilation is like. Okay, so the coordinates of the pre-image, so remember your pre-image, that is the original, okay, they get multiplied by a scale factor, which we sometimes use the letter K to show the scale factor. And when you multiply them, that's how you're going to get the image, okay? And remember, the image is the new figure. Now, if your figure is getting bigger, then it is an enlargement. So your shape gets bigger, and that means your scale factor is going to be greater than 1. So for example, your K could be like 1.5, or your K could be 6/5, something where the scale factor is larger than 1. All right, now if it's a reduction, then your shape is going to get smaller and your scale factor is going to be less than 1, but it's going to be bigger than 0. So an example of that would be like K could be 0.2, or your K could be 3/5, something along those lines. So it's less than 1, but it's bigger than 0. Your scale factor is not going to be a negative number. It's always between, if it's a reduction, it's between 0 and 1, and if it's an enlargement, it's something bigger than 1. And now we're going to go over here and we're going to look at some notation. All right, so we're in this box over here, notation. You will see a dilation described to you sometimes like this. This is like the rule. You know how we've done like the translations and the reflections and the rotations, that special notation? Well, we have one like this for dilations as well. So you have the capital D, that stands for dilation, and then your scale factor is going to be this little number that is a subscript here. And then the item being dilated is in parentheses. So this would be a dilation of the figure GHJK, and the scale factor would be 3. So it would be 3 times the original size of GHJK. So now we're going to go and we're going to do some examples. And I'm going to zoom out for just a second so we can read the instructions. Not quite that much. All right, it says, determine whether the dilation from figure A to figure B is a reduction or an enlargement, and then find the scale factor and write a rule for the dilation using dilation notation. All right, so we're going from A to B. So A is the pre-image, and B would be the image. Okay, so from A to B. So now we're going to zoom in. So if we look at this one, we can see A is this big rectangle and then B is the smaller one. So clearly we're getting smaller. So it is going to be a reduction. Okay, a reduction. And then to figure out the scale factor, there's 2 ways we can do this. We can get a coordinate from each A and B and then divide, or you can also count the sides. So to find your scale factor, and this is kind of like a formula, your scale factor is always new divided by old, okay? New divided by old. So A, I'm going to use this point up here. I'm going to use the top right corner, and I have to use the matching one on the figure B, okay? So my new point is from B, so it is at -1, 1. So -1, 1. This is the new point. And then the old point from figure A is at -1, -2, -3, and then up 1, 2, 3. Okay, so -3, 3. Now you have to keep your X and your Y separate, and you really, you should, like, unless it's a scale factor that's different between your X and a Y, you're going to have the same scale factor between them. So we do a new one divided by the old one. So we take our new X, so -1, and we divide it by our old x, -3. So -1 divided by -3, the negatives cancel, so we just get 1/3. Okay, and you can even see the same thing with the y's. If I take my my new y, which is 1, and divide it by my old y, which is 3, get 1/3. Okay, so new divided by old, that's your scale factor. So it's 1/3. And then you can also even tell with the size of the sides here. Look at A, our original, sorry, the original size of A was 1, 2, 3, right? And then now look at the size of B. It's only 1. So new divided by old, 1 divided by 3, 1/3. Okay, now we'll go over here and we'll do this one. We can see we're going from A to B. So A is the small one, B is the bigger one. So it's going to be an enlargement. So that means our scale factor is going to be greater than 1. And again, we can take a point from the new figure and a point from the old figure, and we can divide them. All right. Or we can count here. So we have to be a little bit careful. Check your scale. This line right here is 6. So it looks like we have to be counting by 2. Okay, so this would be 2. This line is 4, and so that one's 6. And it's the same way with the vertical scale. All right, so I'm going to take a point from A. All right. So A, I'm going to use this point right here and use the matching one from B. So it looks like here's 2, and it looks like it's in the middle, so that would be at 3, right? So we're at 0 for our x, 3 with the y, and then our matching point from B, it's still at 0 for the x, and then our y is at 4. So new divided by old, 4 divided by 3. And I have to use the y's because you see my x's are both 0. So I can't tell anything from there. So our scale factor is just 4/3. And that's it. And again, you see it's a fraction greater than 1, which is what it's supposed to be because it's an enlargement. All right, now on this one, it says to draw a dilation of the figure using the given scale factor and then to give the coordinates of the image. Oh, you know what we forgot to do here? We forgot to write our rule, didn't we? So let's go back and do that. So for this one, we would do D, and then it's 1/3 is our scale factor, and we're dilating image, or the pre-image A. And then over here, D, and then 4/3, and again, we are dilating the image, the figure A. Okay, now we can go on. We're going to dilate using the given scale factor, and then we're going to give the coordinates. So we're going to draw the new picture and we're going to give the coordinates. All right, this one, our scale factor is 2. So that means our line is going to be getting larger. It's going to be getting twice as large. Okay, twice as large. All right, so I'm going to take here B, my original is 2, 2, and then I'm going to multiply each of my coordinates by 2. And you have to do this for both the x and the y, okay? Because not only is your figure going to get larger in size, it's also going to move away or closer to that origin because we're dilating centered at the origin here. So it also either, if it's an enlargement, it moves further away from the origin. If it's a reduction, it moves closer in. So you have to multiply both your x and your y. So 2 times 2, our new point will be 4, and 2 times 2 again, 4. So that's our B prime, okay, is at 4, 4. So over 4 and up, 1, 2, 3, 4. So there's B prime. And then now A prime, so A is originally at 2, 0. And again, you're going to multiply by 2. So 2 times 2 is 4, but 0 times 2 is still just 0, and that's A prime. So A prime is at 4, 0. So right there, A prime. Okay, so we can see that our line is twice as long because originally it was 2 units, now it's 4 units, and it's also twice as far away from that origin. Okay, twice as far away from the origin. So just be aware of that. When you do a dilation, it is going to move. All right, now our scale factor here is 1/2, and we're dilating that image A, B, C, D. So again, take your original points. A is at 1, 2, 3, 4, and then we go up 1, 2, 3, 4. So 4, 4 for A. B, okay, it's got the same X value, but here, so we know A is at 4, 4, 5, 6, 7, 8. So B is at 4, 8. C, well, I know A is at 4, so 5, 6 for our X value, and then it's the same Y value as A, so 6, 4. And then D, it's got the same X value as C, so look, it's over 1, 2, 3, 4, 5, 6. And then it's up 1, 2, 3, 4, 5, 6. So it's at 6, 6. And now our scale factor is 1/2. So we're going to multiply everything by 1/2 or divide it by 2. So A prime would be 2, 2. B prime would be 2, 4. C prime would be 3, 2. And D prime would be 3, 3. And then now we plot them. So A prime is at 2, 2. B prime is at 4, 8. I'm sorry, 2, 4. I apologize. 1, 2, 3, 4. So 2, 4. So that's B prime. C prime is at 3, 2. And D prime is at 3, 3. And we can see here our figure is, half as far away, and it's also half as big. So look at the height. Originally from A to B, the distance was 1, 2, 3, 4. Now the distance from A prime to B prime is only 2. So that's all there is for dilations. You just take your original point, multiply it by the scale factor, and that gives you your new point. See you guys in the next one.